Figure 1 shows an arrangement of logical gates. Construct a truth table showing the outputs R, S, and T. So we are given figure 1 and we are supposed to construct a truth table to show the outputs at R, S, and T. So to begin with, I would like us to simplify this circuit. As you can see, we have a mixture of different gates. So to get the right truth table, you have to be able to know the names of these gates and how they operate. So I am going to simplify the circuit as follows. So this circuit can be redrawn as like this. So we have the inputs B and E. These inputs are getting to our gate. This gate is called NAND gate, and the bubble at the end here, the circle at the end of the gate, means that we have a connection of a NOT gate at that point. So in other words, if we can draw an AND gate followed by a NOT gate like that, then after that we have this output. It is being fed to another AND gate. Here we are joining it with A, and they are getting to inside of AND gate to get R. Then we have input C. Input C is getting into an AND gate, so we can draw AND gate followed by a NOT gate, and at the end this is where we have S. Then after that, these two are fed into an XNOR gate. This is an XNOR gate. When we add a NOT gate at the end, it becomes an XNOR gate. The other one is XOR. So we can just draw the XOR followed by NOT gate. So we have the XOR gate followed by NOT gate. And at the end we get T. So the other thing you have to do, you have to note or to write down the output at every step in these gates. And this is what we do. This gate, we write the output. The output will be B times E. Then when they pass through the NOT gate, the NAND gate, then our NAND gate will produce BE, then overall bar like that, complemented. Then after that, we have our gate, this one. We combine this output here with A as inputs to our gate. So at the end there we are getting A and BE complement. We combine A and this output here to get R. So this is the expression for R. Then down here we have AND gate followed by NOT gate, so that we get S. And at this point we are getting CBE. Then we have complement sign. Then when they pass through the NOT gate, S will be, at this point S will be CBE. We complement, then we put an overall complement to cover the three variables because they have passed through a NOT gate. So this is the expression for S. Then after that, we have this output. This is R and S. R and S, we are going to pass them through an XOR gate. And remember the sign for an XOR gate, we have plus sign, then we circle the plus sign. So at this point, we shall get this expression. We just get R. R is ABE. We XOR CBE. Then we have overall complementation. So we XOR R and S expressions to get that. Then the final expression should be T, and we pass this expression through a NOT gate. And when you do that, you will find that at the end, T will be equal to our expression, this one. We negate it, so we are getting A, B, E. We have a complement, then XOR CBE. Then all of these expression we negate it because it is passing through a NOT gate. This point we negate it to get that expression. So this is the expression for T. So now we will make our truth table. Remember the truth table, you have to include all distinct inputs. So our inputs will be 4 of them because we have A, B, E, and C. So you have to include all the distinct inputs to the gates. Then we shall see how we now simplify the truth table by making columns of each of these expressions. So let's look at the truth table. First of all, the inputs are 4, and to determine the number of rows in the truth table, we normally use the formula 4 power, that is 2 power n. We use the formula 2 power n, where n is the number of inputs. So in this case, we have 4 inputs. So we get 2 power 4 to get 16 rows. So we are going to draw the truth table, which is consisting of 4 inputs. And the inputs are S, A, B, C, E. So we have A, we have B, we have C, and we have E. Then so we have those inputs, so we are going to make 16 rows. Then so let's make our 16 rows. So we can start with zeros. So we have 8 zeros for A. Here we are looking at all possible combinations of the 4. So we have 0, that is 1, 2, 3, 4, 5, 6, 7, 8. Then 1, 2, 3, 4, 5, 6, 7, 8. So let me divide it. So that we can have each of the inputs being clear. So we have 16 inputs. Sorry, not inputs, rows, because of 4 inputs. So we have those rows. Now, since we have that, let's continue. So for B, we are going to alternate 4 zeros, 4 ones. So we have 0, 0, 0, 0, then 1, 1, 1, 1. You have 0, 4 zeros, and 4 ones. Then for C, we reduce, we go for 2, 2. And you have to start with whatever logics you started with here. So we are going to start always with zeros. So that is for C. Then for E, we go with 0, 1, 0, 1. So that is the inputs. Those are the inputs. Now, what you do next, let me draw the line here. So what you do next, you include each of these expressions in the truth table so that you'll be able to compute them easily. So we are going to add let me add this one, that is B times E being complemented. I will add that. Then I will also add this and this. Then I add for the final expression for S. Then after that I will go and add another column for this expression, and finally T, I add the expression for T, this one. So in my truth table, I will add an expression for B, for BE complement. I will add another expression which will represent R, which is A, B, E. This is complemented. Then another expression will be for C, B, E complement. Then S, I add for S, this is the one that I've added, so I add the final expression for S. So for S, we have this expression CBE. Then we have overall complementation. Then I will have the expression that is passing through the XOR gate, which is A, BE, XOR CBE. Then we have the overall complementation. That is, we are XORing R and S. Then finally, the final column will be the final column will be for our t, and the t is the when we complement the previous expression. So we are going to have t, which will be given by a be complement XOR CBE. Then this is complemented, the three of them. Then we complement the all of the expression. So that will be the expression for t. That will be the expression for t. So let's have our table covering the up to the last column. So our table is like that. These columns, each of them. So we have these columns. So those are the columns that we have to make in this circuit. Remember, the reason why we are making the main columns is because we want to determine the output at every step in the gate, and we go step by step up to the last expression to get the right logic levels. So in this case, now when you have that kind of a table, and you have the inputs, now it's performing the various logic operations represented by the expression in our table. So let's start. This one is BE. This means B. We can use the mathematical terms. This is B times E. Then the answer, we complement it. So we are going to take the input of B and E, and we multiply, and what we get, we complement. So for example, if it is 0, we multiply with 0, we normally get 0, and when you complement 0, you get 1. So at all points where you are getting 0, you will complement and get 1, and at the point where you multiply and get 1, you will complement and get 0. So when you do that, you will get this table. So we shall have 1, 1, then we have 1, we have another 1, another 1, we have a 0, because we are multiplying 1 and 1, we get 1, we complement, we get 0. So after that, we get a 1, we get 0. We follow with 5 ones. After that, we have 0, we have 1, and we have 0. So you are going to, when you use whatever I've said, you get that. Then the next column, which is the representation of R, we are getting the input A, and we multiply with what we have gotten in our column BE complement to get R. So in this case, we are only getting whatever is in A, we multiply straight away with what is in BE column. So in that case, when you take and multiply all this, you'll get, we'll have 0, 0. We'll have that table up to there, because as long as one of the variables is 0, you'll get a 0. So as you can see, from here to here, A is 0, so all of them will be 0 up to that point. Then after that, we will have ones here, Then after that we have a 0, 1, 0. Then after that, the next column is the input C multiplied with the BE. So we are going to get C and we multiply again with what we have gotten in BE complement. And when you do that, you'll get 0, 0. We have 1, 1. We have 0, 0. Then we have a 1. We have 3 zeros. Then we have 1, 1. We have 2 zeros. And we have 1, 0. So that is CBE. Then after that, we go now to the expression that is giving us S. So what we are doing, we are only getting this column and we are complementing it. And as you can see, our table is being simplified when you have the multiple expressions. So now we are only complementing what we have gotten in the previous column. So if it is 0, we will get 1. And if it is 1, we'll get 0. So this is 1, 1, 0, 0, 1, 1. We get a 0, we get 1, 1. This is also 1, 0, 0, 1, 1, 0, 1. That is what we'll get for S. Then the next expression, we are getting whatever we have gotten in S, that is S, we are getting S and we are XORing with R. So this is R and this is S. And XOR gate operates in such a way that if the inputs are at different levels is when you get a 1. And if they are the same, you get 0. So if we find somewhere where the two expressions, one of them being 0 and the other one having 1, at that case we shall get a 1. But where we have 0, 0 or 1, 1, we shall get a 0. So for example, if we have this R 0 and we have S 1, we get 1. But at the point where we have R being 1 and 1 for S, we get 0. Or where we have 0, 0, we'll get 0. So when you follow that format, you shall have 1, 1, we have 0, 0, we have 1, we have 1, we have 0, 1, we have 0, 0, we have 1, 1, we have 0, and we have 3 1s. So that is what we'll get. Now, this is R and S. They have been passed through the XOR gate. Now we are going now to get our final expression for T, and T will be gotten when we pass whatever we have gotten in this step through a NOT gate. So in short, in our truth table, we are only complementing whatever we have gotten in the previous column. So when we complement, we shall get 0, 0, 1, 1. We have 0, we have 0. We have 1, we have 0. We have 1, 1. We have 2 zeros. We have 1. And we have 3 zeros. So that is the final truth table that you should have. So when you are given such a logic circuit, you have to write what is important, write the expression at the end of every gate and make sure to include such a column. And also, if we have some bumbled gates, you can split them, because the bumble at the end means that there is a connection of a NOT gate, and at the end of it you'll find a simplified form of the truth table.